Alright, welcome to lesson 11-3. This is on distance and midpoint formulas. So by the end of this lesson, you should be able to find the distance between 2 points on a line. So say you have a line AB, or segment AB. You should be able to find the distance here between these 2 points. You're also going to be able to use the midpoint, find the midpoint, so say it's midpoint C, of segment AB using the midpoint formula. Alright, so to get started, let's talk about if we have a graph. So if we have a graph, we have our x-axis and our y-axis. This is the origin. I'm only showing the first quadrant of this graph. And I have point A at 2, 1. 2, 1. Oops. Sorry, that's 1, 2. And I have point B at 1, 2, at 7, 3. So there's a line connecting point A and point B. And I want to find, say I have like an imaginary triangle connecting between point A and point B, and then it's an imaginary point C at 7, 2. So I've made a triangle out of this from points A and B. I made a right triangle, and I can use the Pythagorean theorem to find side AB. Right, the segment AB. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. Well, so in this drawing, AB is my hypotenuse. It's the hypo. So it's the longest side, so it's C. So it's going to be a squared, or AB squared equals, and just looking at this line here from A to C, that's 1, 2, 3, 4, 5, 6. Well, let's backtrack. So I know it's going to be AB squared equals, then I have a side AC, so AC squared plus side BC squared. So I can find, I don't know what AB is, but I can find what that is using the Pythagorean theorem. So AB squared equals AC. I can do, look at the, it's on the, it's a horizontal line, so I can look at the x values. So I do 7 minus 1, right, my x values here, for C and A, plus BC. I can look at the y values. So B is at 3 for my y value, and C is at 2 for my y value. So 3 minus 2 squared. So AB squared equals 7 minus 1 is 6 squared, plus 3 minus 2 is 1 squared. So AB squared equals 36 plus 1. So AB squared equals 37. So I can take the square root of both sides in order to get rid of the squared here. So AB, segment AB equals the square root of 37. Whoops. 37. So that's one way. I now know my hypo is the square root of 37. That's one way to find the segment. The length on like a coordinate grid, it's a diagonal line, so you can't find it by just subtracting the side lengths. So a diagonal line on the coordinate grid, you're going to need to either do the Pythagorean theorem, or you can use the distance formula, which is what I'm going to teach you right now. The distance formula is a shortcut way, it's derived from the Pythagorean theorem, and so it cuts out a few of the steps that we just had to do. So the distance formula is one you're going to need to add to your bag of tricks. Just like you know the Pythagorean theorem is a squared plus b squared equals c squared. The distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So essentially it's taking that Pythagorean theorem, so it's for any x1, y1, and x2, y2 points on a coordinate grid. You're using this formula right here, the distance formula, in order to find the distance between just 2 points on a coordinate grid. So I'm going to show you this. So example 1. If you have A is at 6, 3, and then you have point B is at 1, 9, you don't even need to graph it and then draw this imaginary triangle. The distance formula shortcuts that for you, so you don't have to draw out a graph and then plug in the Pythagorean theorem and simplify. The distance formula just take these 2 points, these 2 sets of points, and plug them in, and it's plug and chug to find the distance. So we're going to say our A value is x1, y1, and then we'll say B is x2, y2. It doesn't really matter which one, you just have to pick, say, either A is the x1, y1, or B is x1, y1. You just have to be consistent. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in here. Distance equals the square root of x2 is 1, x1 is 6, so 1 minus 6, in parentheses squared, plus y2 is 9, minus y1 is 3 squared. Alright, so distance equals the square root of 1 minus 6, so negative 5 squared, plus 9 minus 3 is 6 squared. So the distance equals the square root of negative 5 squared is 25, plus 6 squared is 36. So the distance equals the square root of 25 plus 36. So the square root of 61. And you can just leave it like this in radical form as your answer, rather than this would be the exact distance if you leave it in radical form. If you want to go ahead and put it in your calculator and solve for it, you could get an approximate distance. The distance equals, you have to do the squiggly line because it's approximate because you're rounding, 7.8. Okay, so either one of these would be acceptable as your end answer. Alright, I'm going to have you go ahead and do an example with this. So example 1A. It's going to be the same thing. I'm going to give you 2 points, and you're going to use the distance formula to find and solve for the distance. So if you have points 3, 8, and 2, 4, go ahead and solve for the distance and round your answer to the nearest tenth. So find the approximate distance. Go ahead, pause the video. When you've solved the problem, hit play. Alright, so for this problem you should have found that your distance equals 4.1. Oops. Your distance is approximately 4.1. So you should have plugged it in. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You should have written above each each set chosen. Okay, so say this is, you could have picked this as your x2, y2. That's what I'm going to do here. If you did it the other way, that's fine as well. In the end, your answer is going to be the same. This is x1, y1. So I'm going to go ahead and plug this in. Distance equals the square root of my x2 value is 3 minus 2 squared plus y2 is 8 minus y1 is 4 squared. So the distance equals the square root of 3 minus 2 is 1 squared plus 8 minus 4 is 4 squared. So the distance equals the square root of 1 plus 16. Distance equals the square root of 17. Go ahead and plug that in your calculator. Get the approximate 4.1 when you round to the nearest tenth. Alright, so you can use this distance formula in order to solve geometry problems such as like finding area or perimeter. So we're going to go ahead and do that. Example 2, finding area and perimeter. For example, if I have a coordinate grid with, I'm going to count by twos. -4, -6, 2, 4, 6, 2, 4, 6. And my y, my x-axis. Okay, so if I have at -5, 0, point D, and at -1, -3 is point C, at 1, 8 is point A, so 1,8, -5, 0, C is at -1, -3, and then B is at 5, 5. And so I have 4 points on this graph that form together a rectangle. On this rectangle ABCD. And so if I were to, a problem were to ask you to solve for the perimeter or find the area and perimeter of ABCD. Well, in order to find the perimeter of any rectangle, you need to know all 4 side lengths. We don't know what the distance or we don't know what the length of each of these sides is because we're not given side lengths, and it's on a diagonal on our grid. And so we're going to need to use the distance formula in order to find the 2 side lengths, our length and our width, because remember perimeter equals 2 times the length plus 2 times the width. Area equals length times width. So I need to find the length and the width, right? Length and width of my graph here. Length and width is what I'm going to go ahead and find. So I'm going to plug them both into the distance formula and find both sides. So say I want to find, you can either, you can either find side DC or AB. They're going to be congruent. They're going to be equal to one another. First, I'm going to use AB as my example. So if I want to find side AB as my width, AB is going to equal, or the distance of AB is going to equal my distance formula. Remember, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so I'm going to plug in. I'm going to say that point B is going to be x2, y2, and then point A is going to be my so x2, y2 is going to be point B, and then point A will be my x1, y1. So I'll do 5 minus 1 squared plus y2 is 5, y1 is 8, minus 8 squared. So AB equals the square root of 5 minus 1 is 4 squared, plus 5 minus 8 is negative 3 squared. So AB equals the square root of 16 plus negative 3 squared is 9. AB equals square root of 25. So AB equals 5. So now I know my width is 5. Width equals 5. I'm going to go ahead and flip to the next page. We're going to go ahead and solve for, let's look at BC. We'll use the points from B and C, 5, 5, and negative 1, negative 3. So 5, 5, negative 1, negative 3 are going to be my two sets of points. So I'm going to plug them in the distance formula. Let's do x2, y2. This will be my x1, y1. So the distance equals the square root of x2, 5, minus x1, negative 1 squared, plus y2 is 5 minus y1 is negative 3 squared. Distance equals the square root of 5 minus negative 1 is 5 plus 1, 6 squared, plus 5 minus negative 3 is becomes plus 3, 8 squared. Distance equals the square root of 36 plus 64. Distance equals the square root of 100. So distance equals 10. And this distance was side BC. So BC equals 10. So let's flip back over and look at this. So now my length equals 10. So now I have length 10, width 5. I can plug in and find my area and perimeter. So area equals perimeter. Area equals length times width. So area equals 10 times 5. So my area equals 50 units squared. Perimeter equals 2L plus 2W. So perimeter equals 2 times 10 plus 2 times 5. Perimeter equals 20 plus 10. Oops. So perimeter equals 30 units. Alright, so I'm going to have you go ahead. I'm going to draw another coordinate grid. I'm going to have you try this example. This is example 2A. You're going to find area and perimeter of triangle DEF. So I'm going to draw triangle DEF for you. D is at, let's do negative 1, negative 2, negative 3. D and 1, 2, 3. 1, 2, 3. So D is at negative 3, 1. F is at 4, 0. And E is at 0, negative 3. triangle here. There's a right angle. Angle DEF is a right angle. So you're going to solve for the area and perimeter of this triangle. Remember to write out the formulas for area and perimeter of a triangle. And then to pause the video when you've solved for it, area and perimeter both, go ahead and press play. Alright, you should have found that the area, your answer should have been area equals 12.5 units squared, and your perimeter equals 17.1 units squared. I'm going to go ahead and work through this problem really quick so you can see, make sure that you did your work right. So you should have started by saying, okay, the area formula equals 1/2 base times height. Perimeter equals side A plus side B plus side C. So all three sides. So you needed the distance of all three sides in order to find the perimeter. So let's go ahead and we'll write out our distance formula. x2 minus x1 squared plus y2 minus y1 squared. So I'm going to look back over at my grid here, and I'm going to label sides A, B, and C. This is also, remember the right angle is where your base and your height is going to be. Doesn't matter which one's which. So I'm going to go ahead and find side A first. So side A is segment EF. So I'm going to find the distance of EF. Equals the square root of, when I look at my endpoints, I'm going to say F is x2, y2, E is x1, y1, so 4 minus 0 squared plus 0 minus negative 3 squared. So EF equals the square root of 4 squared plus 0 minus negative 3, 3 squared. EF equals square root of 16 plus 9. Looks familiar from another problem. EF equals square root of 25, which equals 5. Okay, I'm going to go ahead and solve for side DF now. Okay, so side DF, I'm going to say F is still my, I'll go with x2, y2, and D is my x1, y1. So, D equals the square root of 4 minus negative 3 squared plus 0 minus 1 squared. So DF equals square root of 4 minus negative 3, so 4 plus 3 is 7 squared, plus 0 minus 1 is 1 squared. DF equals square root of 49 plus 1 is square root of 50. I'm going to leave it as the square root of 50. It's important as you're doing these problems to leave the radicals until the very last step. Now I'm going to go ahead and solve for my third side. Side DE. So side DE equals the square root of, I'm going to say, in this case, D is my x2, y2, so negative 3 minus 0 squared plus 1 minus negative 3 squared. So DE equals the square root of negative 3 minus 0, so negative 3 squared, that's 9, plus 1 minus 3 is 1 plus 3. So that's 4 squared is 16. DE equals square root of 25, which equals 5. Alright, so I have A and B are both 5. Inside B is 25 here. Oh, whoops, sorry, not 25. It's the square root of 50. DF is square root of 50. So I can go ahead and solve for my area and perimeter then. So area would equal 1/2 base times height. So area equals 1/2 times 5 times 5. Area equals 1/2 times 25. So the area equals 12.5 units squared. Perimeter, you're just adding up all three sides. So here's where you can take and round to the nearest tenth when you're solving for the square root of 50. So it'd be 5 plus 5 plus the square root of 50. And you get your perimeter equals 17.1 units. Oops, not squared, just units. Alright, we're going to skip ahead now to, we've done the distance formula several times in order to find different side lengths, and then once we use those side lengths, clearly we can use them in numerous ways, right? To find the area and perimeter of triangles, rectangles, squares. Those are just ways to use why we would use the distance formula, why we would want to find an unknown side on a coordinate grid. So moving on now, let's talk about the midpoint formula. The midpoint formula is not derived from the Pythagorean theorem, but it just helps you find, if you have AB, helps you find this midpoint, point C, where both sides AC equals, segment AC is now congruent to segment CB, because C is the midpoint. So midpoint formula equals, it's just you're finding the average of AB, and so, hold on, you're finding the average of AB, so if you have point A is x1, y1, and then B is your x2, y2, we're going to be using those coordinates again. So the midpoint formula equals, it's going to be a coordinate point. C is a coordinate. It's like x3, y3, essentially. It's this third coordinate point on the line. So the average, you're taking the average of x1, y1, and x2, y2. So midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So you're just adding up your x values divided by 2, adding up your y values divided by 2. That gives you the average of your 2x values, which is the middle, and then you do the same thing for the y's. So for example 3, we have G at 2, 0, and we have H at 7, -2. We want to find the midpoint of GH, segment GH. We're going to use our midpoint formula right up here. So we're going to say the midpoint equals, it doesn't matter which one is x2, y2, which one's y1, y2, because when you're adding, it doesn't matter the order, or that you're consistent, but I'll go with G as my x1, y1. Oops. and then h is my x2, y2. So the midpoint equals 2 plus 7 over 2, comma, 0 plus negative 2 over 2. So the midpoint equals 2 plus 7 is 9 over 2, comma, 0 plus negative 2, negative 2 over 2. So your midpoint equals 9 over 2, Nine over 2 is 4 and 1/2, comma, negative 2 over 2 is negative 1. So that's your midpoint on that line. I'm going to have you go ahead and find the midpoint of this segment. I'm going to draw a coordinate grid. Oops. X and Y axis. A is this is point A at 5, 3. Oops, sorry, that's 3, 5. And then point B is at 6, 1. Go ahead and solve for, press the video, pause on the video, hit play when you've solved for the midpoint of segment AB. Alright, so you should have found that the midpoint of AB equals 4, 3. I'll go ahead and solve this really quickly and you can check. You should have said midpoint equals x1 plus x2 over 2, comma y2, or y1 plus y2 over 2. So you should have found that the midpoint equals, you take your endpoints and so add your x values, 3 plus 6 over 2, comma your y values, 5 plus 1 over 2, so the midpoint equals 3 plus 6 over 2, so 3 plus 6 is 9. Oops. 9 over 2. Oh, sorry, it should have been 4 and 1/2, comma 3. 9 over 2, comma 6 over 2. So your midpoint equals 4 and 1/2, comma 3. Alright, so your in-class problems to work on today include page 582 in your textbook, numbers 11 through 14. Make sure you show all your work, including writing out formulas, including labeling which endpoint is x2, y2, and which endpoint is x1, y1. Don't skip steps even though it's tedious. There's only 4 problems. Your homework tonight is going to be your practice book, page 411-3. Go ahead and get started.